Dr. Roshan, we wait for some more minutes as others join. And at what time do you suggest we start?
Yeah, well, let's see. Normally we should start 6, but let's see. We can
Yeah.
wait a couple of more minutes after 6. 6:05 is also okay. Yeah.
Dear attendees, we should start in a few more minutes as there are still a lot of people joining in. I guess we can start. Let's say we wait 5 more minutes and then we should start.
Bonsoir tout le monde.
So,
So,
Sorry déjà, moi c'est mon directeur, so je travaille.
no problem at all. We shall start in 1 or 2 more minutes. I guess that most people have joined in by now.
Yes, fine for me. It's you who decides today.
No problem, boss. So I guess that we can start. Can you hear me well, Yashir? Do you hear me?
Yes, Zishan, I
yes,
can hear you.
yes,
Okay,
we can
oh,
hear
good,
you.
thank you. So good evening, ladies and gentlemen, and welcome to our online workshop on artificial intelligence. My name is Zishan Bugali, and I'll be your host for the evening. It is indeed an immense pleasure to see so many people joining this workshop. I guess that we have around 110 people, which is a great thing to see. And I am sure that you will have a fruitful session with us and that you will enjoy this evening's presentation. Before we go any further, please note that this event is a collaboration among the different societies of the engineering community of the University of Mauritius. Namely, you've got the IEEE, the IMechE, the Civil Engineering Society, the Chemical Engineering Society, but you've also got societies such as the UM Oracle Club, and also the IEEE from the student branches of the UTM and also the Middlesex. And all of this was initiated by the student representative of the Faculty of Engineering, Yashil Anoop. Hence, I would like to invite him to share with us the vision behind this event and how it was made possible. Yashil, you're there? Yeah.
Yes, so thank you very much, Zishan. Well, you guys, this event, well, it is a series of events actually, with an aim to provide students with knowledge that our course doesn't give to us. And, you know, we have a really rapidly evolving world actually, especially the engineering world, where nowadays we have AI, which is applied in almost every sector in the industry. And I think that we only have mechatronics and electrical who have course modules on AI. I think Dr. Gouchan can clear this for us. But I think that personally, I think that AI should be something that whatever engineering courses you're following, or even the IT domain, we have students I know who registered from finance, who does finance and registered. Well, AI is also applied in fintech. So I really hope that you guys can have a small guidance from this workshop. And I will share my screen actually to show you the engineering community. So as you can see, we have a Facebook group that I invite students from FOE, from engineering, and also our alumni to join, because from this that we raise awareness on different events that we do. And actually we have, well, lots of members, and we should continue to keep this growing. And well, this was initiated a few years ago from students themselves. And then later, as we develop and build everything, I created this YouTube channel, the Engineering Community. As you can see now, we are live. You can also find on it different videos about workshops that we did or webinars that we did. And sometimes we make useful videos actually for example, how to calculate your CPA, how to enroll for module, and I will be posting one on why there's a caping for receipt, for both receipt and retake, and why this is actually for the best interest of the students. Okay, and yes, well, actually, this, I said, was created by students, for students who were here, students who are here right now. And there's future pillars of FOE actually. Some are gone, some remains, and I'm really confident that the next generation, well, it's not a generation actually, the next years, the next batches will do a fantastic job because we are really building a strong base for them to grow and expand. Well, right now I am the one talking to you actually, but there's really this amazing team that is working in the background, and each and every webinar session you will be discovering one of them. For example, we had today we have Zishan, and for the previous webinar we have on circular economy, etc. We had different hosts, so these are the ones that will be leading FOE actually. So that's all for me, and back to you, Zishan. I think you're muted, mate.
Oh, sorry, Ashil. Always, as I was saying, it's always good to hear your motivating and refreshing words. So this, as I just mentioned previously, we have a collaboration of many engineering societies for this event. And hence, I would like to invite the chairperson of IEEE from the student branch of UOM to come and talk to us and give us a little insight on what exactly is an engineering society and what are the benefits of joining one. His name is Hamkesh Nyamal, and I leave the floor to him. Hamkesh, you there? Yeah, it's good. Thank you, Hamkesh, for this nice introduction. Indeed, I guess we can move on to our main subject now. So, as Yashil just mentioned previously, this evening is the first session of a three-part online workshop on artificial intelligence. On the agenda for today, we have a small introduction on what exactly AI is, the goal, the trends, and the achievements. We will also explore some areas of the application of AI. We will get to know some neural networks such as biological and artificial, and I guess we will finish with Boolean logic as a training set for neural networks. Yeah, that's what we will have for today, and then we'll have a small Q&A session, followed by at the end of this presentation, we will send you a link. On this link, you will have to input your name so that we will be able to collect your attendance for this session. And only those who have attended all 3 sessions of this workshop will be eligible to obtain this certificate of attendance that we will provide. So to enlighten us on this topic, we have with us today Dr. Mahendra Guruchan. Dr. Guruchan works as a senior lecturer in the Mechanical and Production Engineering Department of the University of Mauritius. He's a chartered engineer registered with the Engineering Council of the UK and holds several professional engineering memberships. I guess that it will take us too long to go over the entirety of his impressive bio, but I can just say that those who have worked with him describe him as one of the best that our Faculty of Engineering has to offer. So it is hence my honor to invite him to start his presentation. And sir, you can? I'll leave the floor to you.
Yes, thank you, Zishan. Thank you very much. And thank you very much for the introduction. It's nice to get the feedback from you that students appreciate my work. So thank you very much. So I'm just going to share my screen and get started. Yeah, so I hope you can see the slide.
Yes, sir, it's good.
Okay, can you hear me well as well? Is it my voice is coming clear?
Yes, sir, everything's okay.
Okay, thank you very much. So again, thank you very much for Student Societies for giving me the opportunity to address you on a topic which is very dear to me. I've used it extensively as part of my research, so I hope today I will inspire you. But of course, we have around 3 hours together for the 3 parts. So I will try to give you the main highlights and also give you directions to how you can learn further on your own, because in 3 hours, we can just touch really the main points on it. But in today's session, I really want to cover the debates going around artificial intelligence. What is artificial intelligence really? What are we aiming at? So in the future, if you are actually studying anything related to AI, you would know actually what are we trying to do. So this is really my aim today. And I also be inviting your inputs. So this is how I've been running the workshop. Like Yashila said, it's going to be quite interactive and requesting you to engage, not just like a one-way traffic. So as we go along, there'll be slides. We are going to request your inputs through Mentimeter. So that's something very nice, and I would really look forward to hearing from you. Now, a word of caution here, as you would expect, this is not a normal topic, AI. If you start going into it, maybe you've done that already, you would start seeing that AI would challenge you. Actually, when we try to study AI, and if you really see the core aim of AI, we're trying really to replicate our own intelligence. So the question would come back to us, who are we really? So as I'm going along here, you would have, this is why I put the slide always in my lectures or in the workshops I run. You will need to be prepared to be challenged. Yeah, to be challenged and to start questioning yourself, because as it turns out to be, we don't really know who we are really. This is one of the main challenges in AI. We're trying to replicate human intelligence, but when we start studying human beings, we see that, yes, we don't know ourselves actually. So how could we try to replicate our own identity, our own intelligence? So as we go along, I'll be sending some questions and really inviting you to give your opinion. So I hope all of you are adults here, so there should not be any issue, but there might be some topics where you've not really thought about that and it will be challenging for you. So be ready for that. Okay, so briefly, what is artificial intelligence? So AI is a study of how to build computer systems that exhibit intelligence in some manner. So this is where the name comes, artificial intelligence. So as we go along today, I'll be trying to show to you that intelligence is they have used the word intelligence, but as we start trying to define intelligence, like anything which we do in engineering or science or any field, we want to have some objective definition for it, just like you have all the laws of, let's say, Newton's laws. All these are fundamental laws, which are very, very important for us to build upon and to create new knowledge. So when we define, it becomes very important for us to understand what is intelligence. So we're going to try to spend some time on that today. But the word artificial is maybe well understood. Artificial is something which maybe is man-made. That will be quite easy for us to do. Now, the second bullet point to find that AI research is still in its early phase. So actually, it dates back to 1960s, even 50s. But why we're saying it is still is in early stage, because people are investing so much effort in the field of AI. If you just go on Google and type AI, you're going to find millions, even I would say billions, but lots of articles, and you'll find lots of areas like our host has been saying earlier, Yashin has mentioned, there are so much application now for AI. This is where the appeal is now for you. Whatever field you are in, I guess you are at the university, you would have studied basic mathematics, you would have studied physics or biology even. So it means there is something in AI for everyone, irrespective of background. So at the Faculty of Engineering, we tend to have modules of AI for mechatronics students or electrical students, but any student, if you start reading mechanical engineers, chemical engineers, civil engineers, everyone would use AI somehow, even agriculture, in mathematics, in science, biology, whatever field you are in. Even now, AI is used immensely in stock market prediction. Yep. So as we go along, we're going to see what are we trying to achieve for AI? Why is AI being used so extensively, especially now with ever increasing more and more powerful computers, microprocessors, microcontrollers. So it is really increasing the potential to apply AI. So this has been an important breakthrough as well. Why AI is being used so much is because we had in parallel, we had increasing memory capacity. In very small space, we can store lots of data now, and also processing power. So all these have gone together to make AI really now one of the field which you would want to get in, even if you don't become an AI engineer. At least you should know what it is, because people will talk more and more about it in your career as you go along. Now, I just want to play this 2 short video. Actually, this will be more relevant for next week, but I just want to give you an idea. What are we going to? Now, we are talking about AI today, more, which is artificial intelligence, but my specific topic as we go along will be on deep learning. So deep learning, the word deep learning relates to our neural network in our brain, how our brain works, and how we're trying to copy the way our brain works into machines. This is what will be the topic, but AI is much more broader. The bigger topic there is AI, but in AI, as I'll be explaining later, you have lots of subtopics like fuzzy logic, genetic programming, object-oriented programming. So one core area which is becoming more and more important and taking more prominence now is called deep learning. So I just want to show you 2 videos. We'll come back to this afterwards as well. So I just have to share my sound. So I'm just going to pause this and just share my sound, make sure you can hear it. Yeah, my sound is sharing. So if you cannot hear me, you would have to, there's a sound, you have to let me know. Was it okay?
Yeah,
could you hear the sound?
It's okay, sir. Yeah, we can.
Okay. Let's have a look at that, and then we're going to discuss.
This is a project done on how neurons fire.
Presented by Nikita and Skylar.
As millions of volts light up the sky during a lightning storm, our human brain models this on a much smaller scale. Electrical energy and chemical impulses are essential for communication throughout the nervous system. The basic unit of that communication is the neuron. These neurons communicate between each other, They receive information and transmit information. Approximately 100 billion highly specialized cells can be found in the human brain alone. Their basic structure is the same, consisting of the cell body, dendrites, and the axon. These neurons are essential to life because they make us do what we do and say what we say. Wow. The basic structure place where all the metabolic activities the cell body, the synthetic center of the cell, is the cell body. The dendrites receive messages from other cells. The more branches a dendrite has, the more information the neuron can receive.
Axons pass messages away from the cell body to the other end of the cell. The role of the axon is to then convey that message to other neurons, muscles, or glands.
Unfortunately, the inter-body communication system can malfunction.
Okay, students, so this is part of a video. Actually, you have seen lots of descriptions in there, which we will cover in detail in the second part. I want to play second video now to you. Of course, these videos are available on YouTube. So I will send the links to you. You can see it afterwards after the session. So I have a second video which I want to show to you. Stop sharing, not showing you. This one. Is that all right? Can you listen to it? Can you see it?
We can't actually see it.
You can't see it yet?
But we can hear it.
No, you have to see it. So let me just check. I think I need to share again. Maybe I'm not sharing my full screen. Stop share and share again. Okay, and then... Can you hear it now? Can you see it?
Yeah, it's good. Sir.
Okay, yeah, let's look at that. This one is short actually, and it's going to also be about neurons.
We know about the inner workings of the human mind. Surely everything that humans do, from designing skyscrapers to composing symphonies, is not the product of simple cellular interactions. And yet it might be. Because everything that humans do, or think, or feel, is a result of these basic units of brain structure, the neurons. The human brain contains more than 100 billion neurons. Just like a single ant could never build an anthill, a single neuron can't think or feel or remember. A neuron's power is a result of its connections to other neurons. Each neuron is connected to as many as 1,000 of its neighbors. These trillions of connections provide the playing field upon which the complex activity of the brain takes place. Each neuron can turn its neighbors on or off depending on the signal it sends. And the resulting stable patterns of neuron firing represents memories, and images, and thoughts. We don't yet understand the relationship between neural activity and mental experience. We don't know what the precise pattern of memory or an image or a thought looks like. We don't yet know how to read the cerebral code of the neurons, but progress is being made. We can now watch exactly how various stimuli and memories cause the firing of hundreds of neurons. Perhaps these techniques will allow us to work our way up from the activity of a few neurons to see the structure that emerges from the whole.
Students, so let's move from there. So I hope this was quite inspiring for you, but at the same time, when you look at this video, you're going to start realizing how little we know about ourselves. This would have been like in our brain, we have such a complex mechanism going on. And really, when you look at how the field of neuroscience is trying to map how a brain activity is related to different things. For example, if you are learning a new language, or when you're seeing a scene, there are certain areas in the brain which are activated, or when you're trying to play music, or you're trying to do some mathematical problem solving. So there are specific areas of the brain which are known to be active and to represent certain functions. But like in the videos mentioned, this is why I mentioned it's a still very active area of research, because when we find these areas of the brain being activated, we see, yes, they are active, the neurons are firing, as we'll be seeing as we go along, but we don't know how this firing of the neurons actually lead to knowledge or leads us to be able to make sense of information. We don't know that. So as I'm going to go along today, you will find how little we know about ourselves. So don't be shocked about that. It's actually maybe a good thing if you want to also have in our life, as we are developing professionally. It's also important that you to take care of yourself, and you also look into, like we talk, self-realization and knowing yourself. This is also a very core, if you want, area you have to look at, and AI is going to push you to do that. Yeah. So we're going to come back. What you see in this video is a very important content where we actually have the basic elements for us to start modeling mathematically. Of course, what we're going to try to do is a very simplistic model of actually trying to model how our neuron works and how we can start replicating that in a computer and start connecting the neurons together to be able to get a neural network. And then from there, you can do fantastic work. But the neurons we will model actually mathematically are nowhere close to our neurons, our brain. They are much more powerful. This is why we are so good in making, if you want, decisions, in making high-level decisions, which computers actually don't have this capability. So a major point of contention, if you look at the video, is of the field of AI, is whether computers can think. So we are talking here about artificial intelligence, and we are trying to, in a way, make computers think. Yeah. So then there are lots of debate going on. It's like, can we really consider a computer as a machine? Can we consider a computer to be intelligent as us? So what's your view on that? So I've created a small Menti sheet there for you to just tell me your views. It's really your view. There's no right or wrong here. It's really your view. So do you think that computers can be considered to be intelligent, or there's no chance that a computer can be considered to be intelligent? So you've got the QR code there. You've got also the link. I'm just going to copy that and paste in the chat. So you can just, maybe that's easier for you. But if you've got a small device like a smartphone, you can just scan the QR code as well. So just quickly just give your thoughts on that. Do you think computers can be considered to be intelligent? Because that's the whole aim actually of AI, is to make computer systems become intelligent or replicate human intelligence. So as you are giving your vote here, I'm just going to map out your inputs. Yep, so as you can see here, a couple of you. So you can see distribution here. We have around 100, over 100 of you here. So I'm expecting lots of more of feedback from you. So currently 7, 9 saying yes, we can consider computers to be intelligent. 3 are saying no, and 3 not sure. So let's give it some more time and see the distribution mapping up in front of us. Like I'm saying, there's no right or wrong answers here. As we go along today, you would see there's lots of debate going on in the field of AI. Now, AI is linked to psychology because we are talking about our own identity here. AI is not just about engineers. So what I'm going to present to you today, the theoretical background of computers, is important because, yes, I've done that. Yeah. Okay, I'll send the link in the chat. Okay. Now, whatever we are studying today is very important because in the future, whenever someone talks about AI to you, you would know what they're talking about, first thing. And also, there are many tools that are emanating from this very search for the replication of intelligence. And one of these is artificial neural networks. There are so many areas coming out. Electrical engineers know about fuzzy logic. This is also emanating from the field of AI. So I think it's very important for you to have a firm grounding, the basis of AI. Then from there onwards, whatever tool emanates from it, genetic programming is another one of them, which also emanates from the field of AI. So this is why I'm covering that today, but also saying to you about the debates going on in the field of AI. And one of them is what you're voting now. Can computers think and be considered to be intelligent? So we can see overwhelmingly you're saying yes, but as we go along, we're going to have the results of a debate, what people are saying, and you would see that there's no clear-cut answer for that as we go along. Yep. So someone saying not sure. So that is perfectly plausible to say not sure, because when you start really delving deep into the problem, and especially when we start thinking of intelligence and when we look at ourselves, for example, I've just shown you a video and maybe you'll be amazed. So many things is happening in your own brain, but you don't know, but your neurons are firing and how you're making sense of this. I give you one simple analogy, for example, which I say to my students in class. Currently, you've just seen me, those who do not know me actually, and you've seen me first time through Zoom today when I turned on my video. You've seen me first time. What it has happened inside your brain, if you think of that well now, that would also be a revelation to you. What has happened inside your brain so that next week when I'm going to do the same webinar for part 2, you will recognize me. What has happened inside your brain? You don't know that actually. Yep. But there are some things which have been inherently programmed in you that you don't really control, I would say. That is happening. The same thing happens if you look at your whole life experience, right from the point when you were a baby, when you started, you don't know how to walk, then you started crawling, then you started walking. What has happened inside your body to teach you how to actually walk, or how to actually speak a new language, or how to sing, or how to say this color? Everything is related to neuroactivity. And this is something central, which you would learn through the 3 days we're going to cover AI. Even if you don't really understand in depth how all this is done, everything that you're learning, whatever skill you're learning, is actually linked to neural activity. And when subsequently we're going to teach you actually very briefly how a neural network can be made to learn, you will also understand how this is happening inside your brain. So always think about you yourself, because the whole purpose of AI is really about us human beings. So as you vote there, we can see, yes, most of you think, yes, computers can be considered to be intelligent, but I'm saying there's no yes or no answer, but I have been quite amazed to see your feedback on that. Thank you very much for those who voted. So let's continue. Okay. So as we go along, there'll be a couple of more feedback I'm going to seek from you. Okay, so I'm not giving my view here. As I go along, you will get the debate going on. Now, where this term AI has been coined, if you look at the history, it was actually 1956 at a workshop called Dartmouth. So these people you find there, they are eminent. Actually, some of them may not be here, may have passed away, but they are eminent people in the field of AI, and they have really put lots of schools of thought, which we will not cover necessarily, but they have the connectionist or the symbolic approach and so on. So they are the people who have really created frameworks for us to have AI. Yep. So that Dartmouth workshop is an important, if you want, step in the field of AI. Now, some examples from my own experience where I've applied AI, just to give you, if you want, an idea where you could apply it. This slide is showing, let's say you have an application where you want to detect, like what you can see here, some features on your face. Let's say you have lots of images. You want to detect the eye corners, like I did in my research, or you have to detect the prominent points on the ear. Let's say you have many images, and then you want to detect these things. So this is one of the objectives I had actually during my PhD in UK. So I've used neural network to do that. So you have many images. You can tell in the images where these locations are, and then the neural network will learn it. So when you give new images to the neural network, they will tell you where the corners are. So if you have a well-trained neural network, you can then predict, you can do decision making. You also can predict how the system will behave. So this is really interesting. Yeah. So this was one application I worked in. This application of talking to you here about detecting the eye corners was really in the field of robotics, where we're trying to guide a robotic system to actually drill inside the human brain to actually do neurosurgery. And what we need to be able to do that is to really detect where you want to go. So this is why I had to detect some features on the human face, so we can actually reference the robotic system to the head. So I won't go in detail, but this was basically the application. Now, another application which I had is the flow of fluid, of blood, for example, or any fluid. So what you can do, you can just collect many images of how fluid flows on surfaces. Yep. And then, for example, this one you find on top there is a start of, this is the first frame, and then the next one is here. So you can see this is all these images correspond to the same flow of fluid. So the fluid starts here, then grows like this. Yep. And this one is another flow, which is now more like a stream. And this one also is the same stream, same stream, same stream. So if you can collect images like this, and then what can you do now? Let's say you have an image like this, and your network can be made to predict how the fluid will flow in the next stage. If you can already have many images of flows, you can make a neural network predict how a fluid will flow. So this is, again, one application I have developed. So this is how it's going to look in image processing. So these frames there can be converted to images like this, and then you can make a neural network learn about it. So I'm not going into detail, just to give you ideas. Another project I'm working in currently is in in detecting diabetes in people. We know when someone has diabetes, their leg would typically become cold or hotter. So what can we do? We can start having samples of people who have diabetes. So we know they are diabetic, and people who are not diabetic. We can take thermal images like this of their foot, and then we can use these images to train a neural network to say, yes, this is the thermal image, the person has diabetes. So this is because you have your training set, you know who's diabetic. And then you also have images of people who are not diabetic. And then once your neural network has been able to train it, this is what we discussed in part 2 and 3, then you can now take new images of people's leg without doing a blood test with them. You can already get a likelihood of it diabetic or not. So you can again see how neural network actually can really empower doctors or can allow you to do quick diagnosis. Of course, there are scope for error there. One important, when you are using a neural network or any learning engine, there is scope that the system would not perform 100%, because we are human beings ourselves, we don't perform 100%. There are scope for errors in us human beings. So how can you expect machines to be 100%? So there is scope there for errors, like we say, recognition accuracy can be 80%, 90%, but still it is giving you some level of automation. So these are a few examples of projects which I've worked in. Yep. So basically what I've just shown to you here is AI would work. For AI to be useful, you need to have parse data. This is what you have seen in all the applications I've discussed with you. For AI to be useful, you need to have data, which actually tells you, is this, for example, like I give you the example of diabetes, you need to have these thermal signatures of the foot to be able to train the neural network. So this is very important. To use AI, you need to have lots of data. So for any application which you have in mind, you yourself working in your projects, if you have parse data and you want to use this data to predict some target parameter, I give you an example. Let's say you want to predict if it's going to rain at some point or not. Yep. So let's say you're collecting the temperature or the cloudiness of the sky, or you're collecting some other parameters. Yep. For example, the strength of signals that you have in the network or radio signals. So you can collect other factors like this. And then if you're able to collect all this information and then you feed that to your neural network, let's say you feed temperature, wind speed, the cloudiness of the sky, and other parameters, and then you are recording, is it raining or not? Once you are doing that, then in the future, when you are actually monitoring the rainfall pattern, you can already predict, is it going to rain or not? So this is really how you can apply neural networks. So again, this slide is reinforcing that. It's reinforcing the fact that you need to have data to be able to actually apply AI. Yep. So this is really to focus on your own projects or any project you're already working on. If you have lots of data, you can use a neural network to predict your process. Now, in the last line there, you find dimensionality of inputs. Yep. So what is dimensionality of inputs? This is a very important topic when you are dealing with AI or neural network. It's basically how many inputs you have. If you have only 2 inputs or 3 inputs, then these can be very easily shown in a diagram. When you are creating a graph, for example, you can draw in 2D. So you have your X and Y. That's very easy. You have a plane sort of. When you have 3D, then you get it in 3 dimensions, you have X, Y, and Z. But unfortunately, when you go to high dimensions, like 4 dimensions, 5 dimensions, you can't show it on a graph. So you're limited. Okay, so how do you deal with that? Neural network are quite good at that. Even if you can't really show how 4 dimensions or 5 dimensions look like, a neural network has no problem to deal with high dimensions. So as you go along, this will become clear as well. Yep. So you would maybe hear the word machine intelligence as well. I've just talked about artificial intelligence. That would make sense. Yep. But machine intelligence is really when you are taking all this intelligence you're collecting or you're creating from your system, then you are replicating in the real world. Let's say you have a robotic system or you have a mobile robotic system, which you are sort of downloading that intelligence for the system to predict. Then we typically call that machine intelligence. As long as it is just a computer system, it tends to be called artificial intelligence. So if you want, you can just think of maybe computer scientists would be more dealing with AI, whereas engineers more with machine intelligence. But it's not very different. It's just a question of the purpose of it. Yeah. Okay. Now, as you go along, so remember you voted already, but now going maybe in more detail about the contention. Yep. So when we start talking about intelligence, yep. So a school of thought would say, especially when you talk about the computer, if you think about the computer system, you have the microprocessor there, which is processing you would know the microprocessor, the chip, which actually processes all the instructions. So does the chip has something which is above, which is not physical? Yeah, what we're trying to say here, is intelligence only physical, or is there something else which is non-physical? This is what we call about the mind-body problem. So again, this is challenging you again about our own identity. Are we fully physical? Or do we have, of course, we have a physicality in us, but is there some components in our personality which is not physical? Yep. So again, I'm asking you to vote here, but maybe this is a bit more tricky for you to answer if you've not thought about that. Again, just do clear-cut answer here. Yep. Again, this question is coming up. Why? Simply because we are again dealing with our identity. When you talk about a computer system, we know we have a chip there, we have charge being flown into it, you have memories where storing data, all this thing is clear. But is there something which is not just physical? Is there something which is non-physical when it relates to intelligence? Yep. So I'm just going to again copy and paste that, and then we proceed in our discussion. Okay, this one we've done. Yeah. Oh, no, this one. Yeah. So I'm just going to copy and paste that in the chat, and I ask you to vote on that one. I think I've wrongly pasted it. This one is better one. Yeah. Yeah. So the one had a slash there. So again, this one, I just want you to collect your feedback on this. A point of contention is about the physicality or the non-physicality. So is everything just physical, or do we have something which is actually which you can't see, but it is there, and this is what's providing the intelligence? We typically call that the mind-body problem. Yep. Some scientists would say everything is physical, but some would say no, we have some elements there which is actually non-physical. And the moment it is non-physical, it is non-material, then science will struggle. So I will talk about that in a few minutes. Just looking at your feedback here. Again, that can be a bit tricky to answer, yeah, especially if you've never thought about it. But like I was saying earlier, it's maybe high time you think about that, because we're talking about ourselves here. So is intelligence physical or non-physical? So many are saying no. Yep. So intelligence is non-physical. So it means if we admit that, we are saying there are certain elements in our personality which is not just physical. If you want to get the correct answer, I have to admit it myself, you won't get it from modern science. You would have to go into your own religious background. The answers are there. Yep, this is where you would get certain things, like in the Bible it is said we are made of soil, for example, earth, and you're going to return to it. But actually, there's a component in us which never dies. Things like this. So unfortunately, modern science is not good at that. Modern science would want to measure everything with instruments which are material. So how can you measure something which is non-physical with something which is material? So this is where you find a big debate going on right from the start of AI about this physicality, non-physicality, mind-body problem. So it's not easy to answer, because the answer is not within the scope of modern science, because modern science would want to use its own instruments, which are actually made of material. But the question would be, the challenge would be, how can you measure something which is non-physical with something which is physical? Yep. So as you can see here, you have a distribution there. Some are saying, yes, intelligence is physical. Majority are saying no. It means there are certain things in our own personality which is not just physical. It's above, you can say it is subconscious or subtle, like we call it subtle matter. You can relate it as consciousness, as mind, as soul, and so on. So these terms are actually there, but this is what complicates the field of AI more, because the moment we start talking about terms which we don't really can define easily, then we will struggle. Okay. So again, thank you for your inputs there. As you can see, maybe less of you have voted. This tends to be a bit difficult for people to relate to, but like I'm saying now, AI really challenges you to start thinking about this. These topics is what you are. So it's important that we also know who we are. And personally, I would say these answers come from your religious background. So if you are in tune with that, you have read the scriptures, you would know the answers actually. But like I'm saying, yeah.
Sorry to interrupt you. I think some of us are getting different questions. For some, they're saying they're getting the questions, who are you?
Okay. 1 minute. Sorry. So the next one, who are you? Actually, the next problem maybe is it the same link? No. Okay. So I pasted the next one. Sorry, Ashraf. So this is the next one here. Who are we? Yep. So you should be answering this first one first, and then we go to the next one. Sorry for that. I think the links were quite similar. Yeah, so I'm going to paste that again. Try to access this one first, and then we're going to look at the next one in a few minutes. Yeah. So access this one first. I can see a couple of you have voted already. So if you can just quickly vote on this one, then I will shift to the next one. Yeah. Okay. Yeah. Okay. Maybe what I will do at this point, so I think what I'm trying to do here for this Menti actually is to encourage you to think about the challenges, the debates going on in the field of AI. Of course, you have your own thought and everyone respect it. No one is there to debate and say it's like this or that. Yep, everyone has a right to debate. As you can see, someone saying not sure. This is definitely the case for, I would say, our modern civilization. We tend to be disconnected from our real self in a way, and this question about who we are really is actually not easy to answer for many of us. Of course, there are many people who may be self-realized within us today. I'm not saying everyone is like this. There are people who may know who they are without any doubt. That's good. It means you know who you are. You are very comfortable with yourself. If not, then you need to explore more. That's what the conclusion would be. So if I can just go to the next one. So I've just pasted the link again. So those who did not do the second one. So this one is really now asking about ourselves. So this would not be as yes and no. It's going to be more an open question here. Who do you think you are really? Yep. So I'm just putting that there as a question. If you can just give, it would be interesting to see how do we define ourselves. This was going to be quite revealing. Yeah. This is really like a word cloud. So I would be really amazed to see your results actually. Yeah. Yep. So some are giving the names. That's true. So this is fine. This is your name. You can put your name. This is you. Yep. But if you, what are we asking here really at the core? Who are you, and are you able to really answer these questions which you were saying about earlier? Are you fully physical? Are you someone who is actually not only physical, but you have a non-physical element in you, like we see in many scriptures? I think all scriptures say that. All religious backgrounds say that yes, we have a body that currently we are embodied, but at some point when we leave our body back, we actually are someone else. So if this is really our definition, it means we can't identify ourselves fully with our body. There are certain other, if you want, denominators or identification we have to look at. Yep. Like one saying, yes, it is physical since one can use intelligence to build creative things. Yes, let me just comment on this one. Yes, it is physical since one can use intelligence to build creative things. Your intelligence, what you're using to create something, since the thing you're creating is physical, does not mean that intelligence has to be physical as well. Yep. So this is not really a one-to-one answer here. You're saying I'm a divine soul, only one reason. So you can see here, I'm saying again, I'm not judging your answers, but by the whole breadth of answers you're getting here, you can see clearly that there is some subjectivity out there, and we don't really fully, if you want, not everyone is in harmony with that. Yep. And maybe this is the tendency of a modern civilization to tend to teach us more about modern science, material science really, and less of this topic. Yep. So this is a tendency, but if you really want to get in touch with your own identity, you need to do your own homework, like I would say. Yep. So thank you very much again for your feedback. I'm not going to comment on that. I just wanted to show you the breadth of answers you're getting here. Yeah. Okay, let's move on. Yeah, so all these things you discuss here is very interesting. So let's move on now. Yeah. So when we say about artificial intelligence or machine intelligence, it's very important to have to know what the term machine is. So is a computer a machine? You can say yes or no. Now the next question we ask is, are humans machines? Yep. If you talk about the physical, non-physical aspect, which some people believe, then you would say yes, our body is like a machine. If you really think about it, and many machines have actually been created based on how the human body works. Yep. So if people say yes, human beings' body are machines, it means we have already achieved artificial intelligence through our own existence. Yeah. What I'm saying here are debates going on in the field of AI. It's not really my own ideology. Yeah. Now, definitely, when you talk about artificial intelligence, it means you have natural intelligence. Natural intelligence is what our biological intelligence, this is what we are. And like I've said, the whole aim of AI is to replicate that intelligence. But what we've just talked about in the videos, remember our intelligence, the foundation of our intelligence, the foundation of how we think and how we react is a neural activity. Yep. So in a way, you can now extend and say, yes, for any entity to be able to have intelligence, they need to have brain function, they need to have neural activity, but that's not the case. There are many entities, there are many, as you can see the first bullet point there are many entities in nature who demonstrate intelligence but do not have neurons. So you can't say that you need to have neurons to have intelligence. There are other types of entities who do not have neurons. Yeah, so neurons are part of the answer. Now, I will send these notes to you. Yeah, you can read that at your own ease, but here we won't have time. What these two persons have done, Legg and Hutters, they are two researchers. Because we are struggling to define intelligence, they have looked at different definitions for intelligence from dictionaries that you can find here, from psychological associations, and also from AI researchers. So there's no need to actually go in detail here, but what they've found in general, so they've taken a synthesis of all these definitions. They are saying, based on the definitions they've said, there are three properties which they've seen, which is common to all these different definitions. First, so intelligence is a property that an individual agent has as it interacts with its environment or environments. Now, this is very important there. It is saying to us there that all agents, we are agents, we are natural agents, but in the future, if you create an artificial agent, the agent would be in an environment. So the environment is very important for you to also understand to be able to create an AI agent. Similarly, our environment is Earth. So if we don't have the Earth, we don't have any existence away from the Earth. That's very important. So an environment is very important for an agent to even exist. The second one is related to agent's ability to succeed or profit with respect to some goal objective. So if you want to assess the intelligence of any agent, of any system, you would have some clearly defined objective. And if the agent can meet that objective, it is actually intelligent. Yep. Third one depends on how able the agent is to adapt to different objectives. This is the core objective of AI, the adaptation. Now, if you look at yourself, when you're learning at the university, let's say you are in your own field, you're learning some theory, you're learning some modules. Basically, we are forming you. So ultimately, when you go out in the industry, you can apply these principles to solve problems. But there'll be problems which you've never solved before or you've never been taught. You will have to adapt. So it means it's key. If you are to be termed as intelligent, you should be able to adapt to new situations and give solutions. So in all what Legg and Hutter are saying, intelligence measures an agent's ability to achieve goals in a wide range of environments. So environments which you've never even seen before. So I have shown you some examples of applications of artificial neural network as a deep learning example. I give you an example of extraction of eye corners or the ear features. Let's say you have some images of a face, which you've used to train your neural network. And then afterwards, you take some images which are very bright or very dark because the environment you've taken the pictures are different. So this would be one example of where the system would have to adapt. If the system is just tuned to work in an environment which is just made of very well taken pictures, but then suddenly when the sun becomes bright or dark, the system doesn't work, it means it's not intelligent. And we human beings are very good at that. Yeah, we are very good at adapting to different situations to give correct answers. Now, this leads us to Turing test. You know Alan Turing. If those who have read about computer system, if you're in IT or whatever background you are, if you read a bit about Boolean algebra, about computer system, you would know Alan Turing. He's a British mathematician. Yep. So he created something called the Turing test to measure intelligence. That would be interesting for us to look at. So what the setup is, if I just explain the setup for Turing test, so you have an interrogator is like a judge. That interrogator is judging between the computer and the person. Now, the interrogator does not know which one the computer, which one is a person. The interrogator is communicating. So they are physically separate, as you can see. So it's like you are in different rooms. The interrogator has come in and doesn't know who is a computer, who's a person. The computer actually is communicating to the interrogator, just like through chat, maybe WhatsApp or any other type like Messenger. And the person is also communicating through messages. The computer is trying to behave in a way Yep, you have to program it. In a few minutes, we're going to talk about that. So that when you're communicating with the interrogator, the computer wants to fool the interrogator into believing that actually the computer is a person. If the computer has succeeded in doing that, it means it would be defined or to be categorized or it will be said to be intelligent. So this is in the eyes of Turing. He created that test, and if again that computer is able to fool the interrogator judge, then that computer will be defined as being intelligent. So this is a Turing test. If you read more about that. Now, of course, there'll be lots of if you want critics about the Turing test, like can the imitation game determine whether computers can think? So really can if you think about how computers work, those who actually have gone to machine language and microcomputers, microcontrollers, you're sending instructions to the computer just execute it. So is a computer really thinking what it is doing? This thing is a core question here. If you are saying computers are intelligent, does it mean computers are thinking, or is they just executing instructions? So this is something for you to think about. Yep. Now, if a simulated intelligence passes, is it intelligent? So what is he saying here? If a computer passes the Turing test, can it be said to be intelligent? This is what persons are saying. How many machines have passed the test? Now, is failing the test decisive? So if a computer failed the Turing test, does it mean it's stupid? Yeah. So these are sort of critiques that have been, if you want, after Alan Turing proposed his test, people, of course, will always criticize. Now, there's a contest you can read about called the Loebner contest, which is exactly on the Turing test. So around the world, you have lots of universities and research institutes. They'll be creating computer systems to compete for the Loebner contest. Yep. And just read this one. In 2008, the best AI systems succeeded in fooling a quarter of the judges. So even if there's a debate going on, is a Turing test actually a proper intelligence test or not? You can see already in 2008, the computer systems were good enough to start fooling people who are interrogating them. And over time now, it is becoming even better and better. You have seen many chatbots, many computer systems, like Alexa and so on. You would say, yes, they are very close to human behavior. They're becoming better and better at that. Now, there's another one you can see there called Deep Blue. Yep. So if you read more in that field, you're going to see there was a system by IBM called Deep Blue. Yep. So what was Deep Blue? It was a system created by IBM actually to play chess. Yep. It played chess, and it actually succeeded in beating the world chess champion. Now, what this system was actually doing, Deep Blue, it was just looking at all the possible combinations you can have on a chessboard and deciding which is the next best move. The computer system, Deep Blue, actually doesn't understand anything about chess. People have just used all possible combinations of the chessboard. I don't know how to play chess myself, but definitely people who have developed Deep Blue, they know about chess. They have covered all possible combinations and they have programmed the system to have the next best move. So basically, you have a camera system looking at the board and then looking at the current combination, the current configuration of the different pieces, and then deciding what the next move would be, the next best move. In that way, the system is just looking at the board and then deciding what the next best move will be based on a search algorithm. Would you say Deep Blue is intelligent or not? So that's a debate going on as well. But irrespective of your answer, the system has beaten the world chess champion, who is a human being. Yeah. So again, that is debatable. Now, there are other things you can read about DeepMind. There's another game, a game called AlphaGo. Yep. So it is actually from Korea. It looks like this, a bit like chess. Yep. So this one also, AlphaGo, DeepMind actually has been able to beat the champion. And yep. And over time now we had a version called AlphaZero, which is based on the latest AI algorithm, and this one is unbeatable. Yep. So really, more and more as we're getting more and more efficient AI algorithms, they are becoming very good, these systems. Even if they are based on search algorithms, whatever you call them, they are becoming very good. Yeah. Now, briefly, if let's say in the future, you want to implement the Turing test, let's say at the University of Mauritius, we say, yes, let's have a team to develop a system that is able to compete for the Loebner contest. What do you need to actually if you want program, or what elements would you consider in that system? First thing, your system should be able to deal with natural language, because the person, when is communicating with you through chat, the person would use natural language. He will not be using machine language, and your computer doesn't understand machine language, doesn't understand natural language. So you need to be able to do speech processing. So this is one fundamental requirement of your system. It needs to have natural language processing. So as you can see clearly here, as people are trying to make computers understand natural language processing, they are getting now very interesting tools. You would have seen these tools. You just speak into a microphone, it types on the screen, or it's able to read text out. So this is what are emanations on the field of AI, like I was mentioning earlier. Second important element you need to have is called knowledge representation. So for anything you do to be intelligent, you need to have a knowledge base. To be able to take decisions, you need to have a knowledge base. How do you represent that knowledge inside a computer? So you need to think about that. Yep. So next two things are, yep. So next one is automated reasoning. The computer is on its own. You won't be sitting there, the developer of a system, and saying, yes, do this or that. The system, the computer would have to decide what answer to give back to the interrogator on its own. And the fourth one, and most important, I would say, for an AI system is machine learning, which means the way to adapt to new situation. Now, I now give you another perspective to this problem. Let's say you was an interrogator. You are given the task to decide which one is a computer and which one is a person. Of course, you don't want to be fooled. You want to take the correct decision. What sort of questions will you ask the computer and to the person to differentiate between the two? Yep. So this is something which you need to think about. You would try to go into areas which is really very difficult for a computer to really understand. And we'll talk about that in a few minutes. What are these type of languages which computers will start struggling about? I've talked about this already, the mind-body problem. So this one is clear. You can read more about that. Now, the counterpart of the Turing test is called the Searle Chinese room experiment. This is what would actually give you, if you want a counterpart of it, what John Searle is saying. He's saying actually the Turing test is not appropriate at all. Computers cannot think. This is what he's postulating. So basically what a Chinese room experiment, if I tell you the setup, it's like in a room, you have one window. Inside this room, you have a person who knows English, but he doesn't know Chinese. But that person has a dictionary to translate English to Chinese. So you are passing, English Chinese or Chinese English. You are giving to the person scripts which is written in Chinese. The person is using the dictionary and just translating into English and giving it out. So the person just did that. What John Searle is saying through this example here is, actually, the person doesn't know anything about Chinese. He's just following instructions in dictionary. So this is what the, if you want, the way of thinking, the hypothesis, if you want, that John Searle puts forward, that actually computers cannot be taken to be intelligent in the proper sense because they don't understand anything. They're just executing instructions. Yep. So this is the view of John Searle here. Yep. So we come across that. As I mentioned to you, there are many topics that have emanated from the field of AI, and we're going to talk about the first one, but you will come across these one as well. Genetic programming, machine learning, which have a whole breadth of tool as well. Yep. Natural language processing, I've talked about that. Object-oriented programming. So if there are people in the audience today who are from programming background, from software, you would know what is object-oriented programming. Fuzzy logic is also a very powerful tool which you can learn you can learn if you want as an extension to what you're doing today. You would know that your washing machine, for example, uses fuzzy logic. You're going to find the name fuzzy logic in many machines. So it is used a lot for controlling machines. Now, if you think about AI and where we are going into, we are really creating machines or systems which can take decisions on their own. If you look at movies, you're going to find, for example, movies with Terminator and robots. They are systems which can think about on their own and take decisions. So this is what really fuels, if you want, the resistance in the human race, if you want, for AI. It can be quite disruptive out there to have systems which can think on their own and take their own decisions. So this is really scary for many of us. Yeah. I've talked about natural language, and if you was an interrogator, what sort of questions will you ask to these systems to actually differentiate between a human being and the computer? This is where the use of metaphors comes in. So I will show you some metaphors. Yep. Look at this. For example, let's say you are developing the dictionary for your computer system. You have the word C because you have to have a dictionary somewhere. You have a C, so you know what a C is. And let's say you define grief. Grief means someone is sad. Now, when we human beings talk, we tend to start using what's called metaphors or analogies. We're going to say sea of grief. If you are too literal or direct in your approach, if you see sea of grief, and then the computer starts getting full around and say sea of grief means there are lots of grief around. And can you imagine that? So you have a sea of water, but you have a sea of grief now. So if the computer doesn't know how to adapt the context, it will make mistakes. Similarly, broken heart. So broken, yes, you can clearly define what is broken. You can define what a heart is. The broken heart is figurative. Similarly, this one is raining man, or time is a thief. He's apple of my eye, or reeks of infidelity. All these are metaphors which we human beings we use a lot, be it in English or the Creole language, but the computer will struggle with that. Why? Because these sort of metaphors is not defined in dictionaries, first thing. And second thing, our language is so dynamic that this sort of metaphors are being used and being coined or created every day. So how can you capture all that? This will be the challenge. So if you are the interrogator, you will start using words like this. Now, this slide is just for you to think about based on what I've discussed already. You can start already thinking about if in your own field, if in your own projects, you have any applications, any problem you want to solve where you have lots of data, or you have images, or you have text, and you want to predict something. So you could be using AI. Now, to be able to cover next week, I'm just going to quickly cover Boolean logic. Yep. So if you've done that in physics at HSC level, or if you, of course, in engineering, you would have done that, or even in IT. But let's quickly do that. Yeah. Now you would know the AND operation is very simple. Why I'm covering that? Because you will be using these operations in the next week to do very simple training of neural network for me. It will become clearer as we go along next week. So the first one is AND operation. As you can see, and you have two inputs here. So this is what your two inputs are, and your output is simply like a multiplication. So basically, your output Q is high if both are high, as you can see here. Yep. Now, of course, when you talk about Boolean logic, you're talking of binary variables A and B. So they can be just true or false or 0, 1. They can't take anything except 0 and 1. You can liken the AND like a multiplication. Like basically you're multiplying, but it's not exactly multiplication. The next one is the O operation. The O operation can be likened to be like a plus. So you again have two inputs A and B here, and your output is, if at least one of the input is high, your output is high. So you can see here, you have 1, 1, 1. When both are low, you have a low. We're going to use that next week. The NOT is very simple, just inverting the state of your input, and you're creating an output here, which is the invert of it. So when A is 0, your Q is 1. When it is 1, it is 0. Now, the EXO is very important. EXO was a major challenge for the field of neural network. We're going to come across that called EXO problem. So next week, we're going to look at that. So EXO is very similar to O operation. If you look at the O here, you have all or ones here. So it's very similar to EXO, but when both the inputs are 1, it's actually 0 here. So this is what's called EXO, means exclusive or exclusively the two inputs have to be different. Yep. You don't take the case of 1, 1 as 1 here. So we just put a circle across around the plus to say it is exclusive O. So we're going to use that as training data set next week. Now, when you look at Boolean logic, you're going to find it is very simple, just 0, 1, 0, 1. But if you think well about that, there are many situations in our own engineering practice or in your own life where you do yes or no decisions. For example, your light is on or off, your pump is on or off, a door is on or off. Let's say a signal in a process is on or off. If you go in the bank, you may be given a loan or you may be rejected a loan. So many applications in the real world are classification type problems, 0 or 1. So if you look at this table, so I can say this is too simple, but these 0 and 1s can be given real life meanings. Yep. So it's not that simple actually. Yep. So these truth table actually can be given very nice meanings. So we're going to expand on that as we go along. Like I was saying, you can consider bank loan application where you're saying you are given a loan. So in that case, 1 can be say you're given the loan, and 0 means you are rejected the loan. And there are many similar situations like this in the real world, even in engineering applications, where you would use 0 and 1s, true or false, open or close, to actually model the state of many variables. Okay. Now, not in terms of time, how much time we have, I would just want to depict something to you. So this is just one book, which if you want to read it, especially if you have Amazon Kindle, if you can read that for free. Yep. So you can just Google that if you want to read more about binary logic. That is 7:13. I just want to do a last thing with you, which will be useful for next week, just to illustrate what I mean by classification and so on. Just I want to show that to you. Let me just do that like this. So I'm just using Excel because every one of us would know Excel. Yep. So I'm not using complicated software to do the training of neural network. So we'll be using Excel as well next week. So I just want to create what you've just seen on the slide, a simple truth table. So as you have seen, it was like this, 0, 1. Sorry, press the wrong one. So like 0, 1, 0, 1. So this was the combinations for one input, and then this was 0, 0, 1, 1. And then in Excel, actually, you have inside it, you have a function n. So I can say is equal to end. And so the end logical function exists in Excel. So this is the first input and the second input. So as you can see, I'm getting false here. Yep. And so I can just drag down. This is your logical, which you've got. So this is 0, 0, 0, and 1. Yep. So I can just write it Q in terms of 0, 1 here, just to show you on a scatter plot. I just want to show that to you. So this is 0, 0, 0, and 1. Yep. So what I'm going to do next, as you can see here, if you consider Q to be having two values, either 0 or 1, you can think of Q of having two classes. So this could mean, for example, reject, yeah, or maybe put another one. This is off, and this is on. You can have many meanings. You could also, like I've just said, accept. No, this is reject. Yep. So it's up to you to give a meaning to what is 0 and 1s are. And this one could mean accept. What I'm going to do now, as you can see, if you think of 0 as one type of response and 1 as another type, you can now create something called a scatter plot, which is very simple for this one. But as we build in terms of complexity, we can do much more difficult problems. As you can see, these 3 zeros here is one type of response, which we call one type of class. You can see this is class 0, and this is class 1. So what I'm going to do, I'm just going to do a simple scatter plot here. This is actually your class 0, as you can see. I'm just going to insert a scatter plot to put that. Insert scatter plot like this. So very simple here. I've created, this is your first one, second one, third one. So as you can see, this point here is 0, 0. Yep. This one here is actually 1, 0. And the dot you have here is actually 0, 1. That's very simple. Now, what I'm going to do on the same scatter plot, I'm going to insert the class number 2 now. So I'm going to say add. I'm going to call this one class 1. And actually, the input X for class 1 is here. And the input for class 2, the other one is here. Yep. And I'm calling this one class 1. I'm just going to edit the first series and call this one class 0. Yep. So very simple scatter plot here, as you can see, very simple. So here you can see you have the orange dot here, it corresponds to class 1. Yep. If you want, I can just insert something here. Yep. Insert a legend for you just to show on top here. As you can see here. So the blue one is class 0. So in class 0, you have 3 dots, 1, 2, 3. And in class 1, you have only 1 dot. So what I can do now, just to illustrate what the neural network will do ultimately, I'll just 1 minute. Yeah. I can't see. So let me just put that in Paint, and you will see it in Paint. One minute, I've not getting access to my, yeah. So this is one last thing which I want to show you what the neural network will do basically. So I hope you can see Paint. This is what we had earlier. So basically what the neural network would do is going to do that. It's going to create a line like this for you. As you can see, you have class 0 and class 1. The neural network will put a line here for you. See what the neural network will ultimately do. Neural network would be able to differentiate between class 1 and class 0. So in a way, let's say you want to replicate the N logical function. The neural network is going to put a decision boundary here to separate your class 1 from your class 2. So when you have combinations of your input that have to produce class 0, which means reject something, is going to be down here. When you have the combinations of your inputs, in this case, you'll just have 2 inputs, but you can have a number of inputs, is going then to give you a response which is above the line. So basically, the neural network, the learning engine is going to create a boundary like this. This is what the neural network will do. Yeah. So this is basically what we're going to do next week. I'm going to again come back to the video we've seen earlier. Remember, you've seen how the neurons fire and so on. We're going to come back to this and try to come up with a very simple mathematical model for one neuron. And once you understand that, you can start making a neuron learn about input patterns to produce an output pattern. And once you can do it for one, you can start replicating mainly to get a neural network. Unfortunately, like I said, in the 3 hours, I won't be able to go in depth of everything. but I just want to give you enough so when you actually go out there and learn things on the web or in textbook, you know what you're reading. Yeah. Okay, so this is where I'm going to end for today. I hope you've got a good background of, I'm just going to cancel the share, a good background of what are we trying to achieve in AI. Basically, it's about replicating human intelligence. And one core area I'll be focusing more on is deep learning. Yeah. Okay, so over to the students now. Thank you.
Thank you very much, Dr. Gourchand, for this insightful presentation. It was really interesting to discover the origin of artificial intelligence and the different perspectives surrounding it. I guess that now we can proceed to the Q&A session, if that's okay for you. And I invite the attendees to send their questions in the chat, and Dr. Gourchand will make his best to answer your question.
While waiting for the questions, Zishan, actually, during the last stages of the session, we had lots of Year 1 students joining in because I actually had a tutorial at the same time. But I will invite them to check the recording that will be available on YouTube prior to next week's sessions. And I will be sending the link actually to them.
Yes. So just a few more informations as well. We will send you shortly a link in the chat so that you may fill in your name to collect the attendance. This is important as we will collect the attendance for participants to all 3 parts of the seminars, and that's how you will be eligible to obtain a certificate.
I can see questions in the chat. So I can see one from Daochen. So can smelling or hearing be used in order to test a computer? Yeah, so as we go into more details about how a neural network works, for example, if you look at our own, the way we actually perceive any signal or any information from the environment, it could be sight, it could be hearing, it could be touch. Now, when we go into deep into that, it is called stimuli. So stimuli basically relates to all the information we can perceive from the real world. And this is actually fed to our neural networks. This is how this is actually modeled. So for example, I'm looking at a scene now. The scene is of different colors. So in our optical field, we have receptors which are tuned to look at different colors, to look at depth. All this information is actually going to be to create firing of neurons. And then these different stimuli would be used to create knowledge about the scene. So whatever information you have, so you mentioned some of them, smelling. So when you smell something inside your nose, you have some receptors which are sensitive to smell, so to molecules of different types of smell. And this would create triggering of neurons inside your neural network. And when the specific neurons fire in a given way, this is how you make sense of that smell. Similarly, if you hear something inside your ear, inside your eardrums, you have also certain receptors, or if you want, you can call them receptors, which is going to stimulate the neurons and create certain stimuli in the neurons. And this is how it's made sense of. So this is how our brain works. Now, if you want to create an intelligent system, if you want to create an intelligent system which is going to use these sort of channels, be it smelling, be it like you mentioned, hearing or sight, yes, this is how you can create actually artificial intelligence system which is able to make decisions. If, for example, the application you're developing, let's say you want to use, let's say you want to develop a neural network to be able to classify different type of flowers. Let's take one example like this. One way you could do that, how will a human being actually do it? It's going to smell the flower maybe, or look at the flower. So how can you develop an AI system to classify different type of flowers? It could be just visual, but it could also, if you have any sensor which is able to tune to different types of fragrance of flowers, you could use that as an input to classify the type of flowers. So it depends on you. Of course, you want to keep it as simple as possible. If your visual data is enough to classify the flowers, you won't go and to look into actually using smell. But yes, you're right. If you had a sensor which could actually be sensitive to fragrance or to smell. Why not? This would be a different signature. This is why I was talking about different types of inputs earlier. Your image is going to be RGB, red, green, and blue. So you have 3 channels already in your camera images. Now, if you're augmenting that with a smell signature, you have a 4th dimension. If you have other sort of features, I call them those other type of dimensions, why not? You can augment that. That's just for sure.
Yeah. I think we have another question in the chat. Yes.
Yeah. So how data science help in AI? Now, data science is definitely, if you want, an area of AI itself. Yep. If you read about data science and you would want to know where it originates, data science is about studying data, especially big data, where you have huge volumes of data, and you want to find patterns and trends in the data. I'll give you one example. Let's say you are studying some process, and let's say you have 10 inputs which you are thinking is important to predict the output. Yep. So let's say you have X1, X2, X3 up to X10. And then your output is Y. But at this point, you don't know which one is more significant, which one needs to be considered, and which one not. So data science, in a very broad sense, would allow you to do some trend analysis to say which of these inputs are most important, what is the influence of one of these inputs on the output, and which one can be actually considered and which one can be actually omitted. Data science is about that. It's really about finding trends and structured data. Now, like I mentioned to you, if you have a data, you can also use the data and feed it into an AI engine, to a learning engine to predict the output. You will get the output. But if your purpose is to understand the structure of the data, you want to understand which input is more important, and you want to do, like you say, factor analysis, you want to understand what are these different inputs, how it's influencing your output, then data science is useful. But if your application is, you don't want to understand what's happening inside the data, you just want to take a black box, you want to feed your input and you want to get the output, because this is how AI is called. Neural network, for example, it is called like a black box science. You don't know what is sitting inside the box, just like our brain is currently for us. It's like a black box. We are seeing things, we are making sense of information, but we don't really understand what is happening inside our brain. If you think, well, if you look at the video and understand the topic of today's debate. So when you will develop a neural network, which can consist of hundreds, even thousands of neurons, you won't bother about going into the neural network, even the artificial one, to understand how the firing of neurons is giving the output you want. You are going to look at the neural network as a black box, and you would feed your inputs and you will get the output. If you're happy with the output, it is according to what you want, you're happy. So this is basically the difference between a learning engine and data science. Data science is going to go in detail of the trends and structure in your data. Yeah. But as I can say, they are related, definitely. Yeah.
So yes, we have other questions in the chat. I think in simple terms, how can someone explain the difference between these three?
Yeah.
AI, machine learning, and deep learning.
Okay.
Yeah,
I'll explain that very briefly. Yeah. So AI, like I said, the whole subject area is AI, because the whole aim of AI is to replicate human intelligence. That is what AI is about. You want to replicate. I give you one example again of AI. Let's say you have a photographer who very well knows how to take pictures, how to find the correct illumination so that you get very good pictures. The photographer is very good at that. Now, let's say you can replicate the intelligence of a photographer in your mobile phone or in your camera so that you can choose the scene correctly and then advise the person that this is the correct place to take a picture. In a way, you've captured the expert knowledge of a photographer and you're using it in your camera. This is basically how you copied the intelligence of an expert into a machine. This is one example of AI. Now, as we've seen, AI is a very broad area. It deals with neuroscience, it deals with psychology, it deals with a human identity, it deals with many things. Because to be able to answer the question of who we are, there are so many things out there which is being done. So AI is a broad, very, very broad topic. Now, in AI now, since the aim, of course, is to be able to train a machine to be able to replicate that knowledge, this is why knowledge learning, machine learning comes in. Now, machine learning is basically the area of AI which takes this intelligence about human being, how we take decisions, and replicating that into a machine. This is what is machine learning. So one branch of AI is machine learning. Yep. And then other branches would be like I said, psychology is going to try to see how, like neuroscience is going to see how cells work. This is not really what is machine learning. Machine learning will use output from AI to really create algorithms so that machines can behave like human beings. Now, under machine learning, you have different algorithms now. Under machine learning, so basically machine learning is to make machines, be it computers or robotic system, behave like human beings or capture the intelligence of an expert human being. Now, under machine learning, now you have so many so many tools. Again, like you have things, I'll give you some examples. Yep. You have K-means clustering. Yep. You have things like neural network is one of them. Yep. Where you are replicating that knowledge. You have regression, you have statistical inference, you have Bayesian learning. So you have so many tools which are there, statistical, and some of them are mathematics, like you have support vector machines. You have a whole range of tools which you can use now to create that machine learning. And one of these tools is deep learning, which is replicating neural networks inside a computer. This is what deep learning is. So the broader one is AI. Under AI, you have neuroscience, you have psychology, you have so many areas going on. One of the core objectives of AI is machine learning. Under machine learning, now you have so many tools. Like I've said, support vector machines, you have regression, you have principal component analysis, and one of them is artificial neural network. And this is what is deep learning. Now, why deep learning? Because as we're going to study in the subsequent two parts, when you will consider neural network, it's going to be very deep. You have lots of layers of neurons your data has to go through, as you've seen the video at the start. So it's a very deep network. So I say deep learning. You're really having lots of layers. Yeah. So I hope I answered the question. Yeah.
So do you think we have time for the two remaining questions in the chat?
Yes, no problem. Yes.
Okay, so we have one question. What kind of unexpected failures might occur in a world built upon AI, and to what extent can it harm humans?
Okay, what kind of unexpected failures might occur in a world built upon AI, and what extent it can harm humans? Now, normally when I run this in my class, remember I've said earlier, what are the, if you want, the resistance, if you want, the fear, rather. This is what I'm looking for, the fear human beings have towards having a society where machines can think about. Now, if you think well about that, human beings are already creating havoc everywhere. You have terrorists everywhere, you have people who are bombing everywhere. So even people are already doing this havoc. Yep. So the fear of actually machines taking over and creating havoc is there, but already humans are doing it. This is what I want to say to you. But the way I see it, personally, when I develop an AI application, I never try to develop an AI system which is going to replace human beings. I think we are here. We know how to produce human beings. There's no reason why we have to create machines to become our babies or to become our parents and so on. Or like, remember, Sophie was in Mauritius. Some people are saying, I want to marry Sophie. You know, you have heard of that. So I hope there are enough girls out there. We don't need to marry Sophie. But for me personally, when I think of AI as creating a system which is going to assist and complement human beings to do our tasks better. This is how I see AI. But you can't prevent people from trying to create robots or machines that's going to be equivalent to human beings. We can't prevent people to go in that area. But this is how I see innovation and how I see AI fitting in our into our context, into our society. Yeah. But the danger is there. If you allow robotic systems to start carrying guns around and they can decide who to shoot, of course, this is going to create big problems for sure. But I don't think we are going toward that unless in the future we have some really maybe ill-thought politicians or leaders out there to do that. But it all depends on politics, really, because this is where the money comes for AI, from governments. And what sort of research are we putting in place, especially in the field of war and warfare and battles? So this is where AI can become dangerous, I think. Yeah. I can see one question on law. I would want to speak about that. Now, very important, remember I said AI is based a lot on data. So unfortunately, currently, as we're talking now and as you're browsing the web and as you're using WhatsApp, these societies are collecting lots of information on you. You would know that, especially, let's say, in your own inbox, you would see when you do some search, already in your inbox, you'll find some messages coming, which is really what you wanted. So these people are spying on you and really doing lots of analysis on the trends, not just yourself, but on your communities, and really giving you information. Maybe that's good in a way, but in a way, they are also getting into your privacy. So this is where we need to set the, if you want, set the barrier, if you want, set the boundary. How far can they take your personal data and use it, and how far you can allow that? This is what we need to really set in terms of legal, because this tool of AI is so powerful. You would know when you start typing, even in WhatsApp, they start proposing next words to you, where you can very facilitate very quickly. So all this is based on AI to predict, based on the previous messages you've written, what the next most likely word would be. That is very useful. I'm not saying it's bad, but it also means they are collecting so much information about yourself, about your buying patterns, what are you shopping online, what next book you're going to buy. These people know all this thing about you. Yep. It seems Amazon knows which next book you will buy, and it's going to try to make you buy it, and so on. So they're already intruding into your life. So is it for good or for bad? That's something we need to decide. I can see another one. In society, there's growing concern that maybe we might not be able to control AI technology. So then if boundaries were to be set, where and how do we set them? Like I said, it is largely dictated by, I would say, by our leaders, because they are investing into research in AI. This is such an important area now, and so much business opportunities would evolve. So it's a huge economic, if you want, in terms of monetary value. Yeah, both in terms of research and the products you're creating. So this is where the funding from governments will be very important. Now, in a way, as you can see, these businesses out there, they need really customer feedback, and to really, it's so competitive out there. They need to find what phone you want and what features you want in your phone. When will your phone break down, and what next phone you buy, so it can show you on the screen. So in a way, they're intruding into your life. It's up to you now to decide how far you are carried away by these things, and to really, you set your boundary. I think this is very important.
So we've got some more questions in the chat. Do you wish to answer them, or do you think you can keep for next session as well?
Yeah, maybe I can just take quickly. Like you say,
All right.
if you read about AI, you find there are so many applications going here. Like I'm saying, AI in hacking and cybersecurity. Yes, it is definitely possible for people who are very good in IT. They can use trends on the web to actually, if you want, use it for cybersecurity in the positive and negative sense as well. They can very easily do that. AI can be used in the field of nutritional sciences. Definitely, if you read on the web, you're going to find AI is used a lot in fields of agriculture to predict things. I'm not in the field of nutritional science, but if you are from this field and you come and discuss with me what your process and what are your factors and outputs, I'll be able to advise you. So this is what the work of an AI engineer would be. I'm not someone, for example, from finance sector, so I will not know how the stock market would change. But if you as expert and you come and tell me, yes, these are my factors and this is what I'm targeting, I can develop an AI application for you. So it means you would need to work with an expert always. Next one is, how far, according to you, will AI be able to replicate sensors and humans' natural intelligence, and to what extent will it be reliable? Actually, what we're going to discuss is not just about zeros and ones, it's also going to be continuous as well. There are more advanced neural network, which is not just zeros and ones. So it is actually possible to have continuous output as well. Now, to replicate the sensors that we have, if you even see our skin, for example, or our visual, our eyes, or our nose, or our ears, is very advanced. So I don't see how in the future we're going to have this sort of advanced technology to replicate that. But the extent to which we need them into our system is just what we want. If, for example, you have a sensor, you have a camera which can collect information about a scene and it's enough, why do we need to go into the detail of having it like a human eye? But there are researchers out there who would want to do a sensor which is just as comparable to human eyes. Now, this is what innovation is about, maybe, but I think we don't need to go to that level. Yep, we don't need to go to that level, even basic, because the more you are collecting information, the more complex your neural network becomes. So we need to be quite frugal in that. We want to use as much as necessary for an application. I don't think we'll be able to replicate the human being as it is, if that's your question is. Yep, because like you say, if you really go into details, if we start looking at the field of AI, there are things coming up like emotions, cognition, consciousness, which is very difficult to define. If you want to have a machine have emotions, but we don't even understand how our emotions originate from. If you feel sad or you feel happy, we say typically it's come from the heart, but really, if you want to really understand where it comes from, unfortunately, we don't have answers for these at this point. Yeah. And this is where maybe you have to be a bit humble to understand, yes, I'm a true believer that we do have as a super consciousness to create all these things. The more you go in AI, you will realize, yes, there are things that have been created and you are one of these creation. You are not the creator. That's an important thing, which maybe would also come if you dig more deep into that. I think we take the remaining ones in the next session. We don't want to keep this one too long, but thank you very much. Next time when we meet again for part 2, so I can continue with these questions. Yeah.
Yes, thank you very much, Dr. Gurchan, for taking the additional time to answer all these questions.
Pleasure for me.
We'll try to keep the other questions handy so that we can get them for the next session. As a gentle reminder, I would like to inform everyone that our next session will be on Tuesday, the 2nd of August, and it will be held at 7 p.m. 7 p.m. And also, we have already sent the link in the chat for you to fill your attendance. Make sure to do so. Once again, Dr. Gurchan, thank you very much for today's evening. We will send the link for today's recording on the mail to our participants. I guess that's it for today. I don't think that we have any more things for today. So
okay, thank you very much, everyone, and pleasure to talk to you. Thank you very much.
Yes, thank you very much.
Gurchan, will you, just like last time, send me the slides also?
Yes, I'll send the slide to you so participants can have a look at it and we can discuss any queries you have. Yes, sure. Yeah.
Yes, okay, thank you.
So okay, we'll send everything to the participants in the mails that they can have a look at it. Yes, very good. Okay. So thank you, dear participants, for attending. Make sure to come for the second session. It will be as much interesting as the first one, even more, I guess. So wish you all a good evening. Take care and have a good night.
Yes, bonne soirée tout le monde. Vraiment encourageant qu'aujourd'hui, nous n'avons pas juste besoin d'Eleven Engineering, mais aussi FOICDT.